Global warming is an issue that is becoming more and more prevalent as more time passes, and a good solution still has not been discovered. One of the lesser-known issues attributed to global warming is the water crisis we will be facing. As of now in the Pacific Northwest, a considerable amount of precipitation comes in the form of snow. As global warming progresses, this pattern will change. Less precipitation will come in the form of snow, and more will come as rain. The problem is that lakes and streams will see lower water levels. Normally, in spring, the snow naturally melts and runs off where it can then be used for irrigation, recreation, public use, and recharging the aquifers. However, in the future with climate change, this natural pattern will cease to exist.
Using a series of household materials, we created a scale model aquifer system that would have both a stream and a lake. In between two sheets of acrylic plastic, we created an aquifer by placing various layers of sand and gravel to simulate a real aquifer. To create a lake and stream, we used a piece of plastic pipe about 1 inch wide and cut it in half. One piece as the lake and one piece as the stream. These pieces were then attached to the pieces of plastic in the aquifer. At this point, we began to place a layer of dark sand from the sandy river at the base of our aquifer. We then placed gravel in the system. After that, a layer of white sand was poured into the model, followed in turn by another layer of dark sand with a final layer of white sand, which was brought up to the level of the lake and stream to simulate the ground. Next, we placed 3 walls made of straws at multiple depths, deep, shallow, and intermediate, each well at a different position in the aquifer. After finishing the construction of the aquifer, we charged it with water using an aquarium pump and a 5-gallon bucket of water. The water was pumped into a vertical standpipe integrated into the aquifer. Water trickled through each layer of the aquifer, including the lake and stream. Once full, the groundwater discharged to the stream and out the outlet that we created. In order to maintain a height of 35 millimeters in our stage, we kept the pump running to discharge 1.14 gallons per minute. We let it run several minutes at this state to ensure that the stream flow of the river and lake were being maintained at a constant water level. Next, we injected 1 milliliter of red dye into well number 1 and into well number 2 also. Pumping water into our aquifer created a fully functional scale model groundwater system. We could see the dyed water visibly rise up and fill the lake and stream. The water in the stream began to run off into a bucket, simulating a real lake. To show the effects of climate change on the groundwater system, we reduced the flow of water that went into the aquifer. The results from doing this painted a bleak outlook for the future if global warming continues. What happened was the river and lake levels dropped 7 millimeters. This creates a drastic change to the ecosystem of the living organisms that inhabit those lakes and streams and the people who rely on them as a source of water.